Hello, I'm Carlos Suarez, and this is the CRS channel. We're going to continue our series of problems and exercises and problems in pre-calculus, and we're going to follow on with word problems. Okay, the first word problem says the following. A player has scored an average of 18 points per game during 2/3 of the basketball season. What must his average score per game be for the remaining 1/3 of the season for his average score per game for the season to be of 22 points per game? We have that our average score per game for the season is equal to the ratio between the total number of points scored in the season and the total number of games in the season. Here we are not considering whether the player gets injured, falls sick, or any other reason that could make him miss any games. So the player has played all the games in the season. So the total number of points scored during the season is equal to the average score per game during the first 2/3 of the season times the number of games in the first 2/3 of the season plus the average score per game during the last 1/3 of the season times the number of games in the last 1/3 of the season. Okay, then putting this up here, we have that our average score per game for the season will be then equal to the average score per game during the first 2/3 of the season times the number of games in the first 2/3 of the season over the total number of games in the season. Now that ratio of the number of games in the first 2/3 of the season over the total number of games in the season is nothing else than 2/3. And again we have the plus the average score per game during the last 1/3 of the season, average score per game during the last 1/3 of the season times the number of games in the last 1/3 of the season over the total number of games in the season. Now, know that the number of games in the last third of the season over the total number of games in the season is nothing else than 1/3. So we can say that our average score per game for the season is 2/3 times the average score per game during the first 2/3 of the season plus 1/3 times the average score per game during the last 1/3 of the season. So, defining our variable x as the average score per game during the last third of the season, and knowing that the average score per game during the first 2/3 of the season is 18, we have then that 1/3 of x, which is 1/3 times the average score per game during the last third of the season, plus 2/3 times 18, which is 2/3 times the average score per game during the first 2/3 of the season, is equal to the average score per game for the season, which is expected to be 22. Okay, so multiplying both sides by 3, I have x plus 2 times 18, which is 36, should be equal to 3 times 22, which is 66. So x plus 36 should be equal to 66, which means that x equals 30. Okay, the next problem is the following. Find the smallest number that is equal to the product of the sum of its digits and the number 13. Okay, first we're going to assume that our number is made up of two digits. So our number is xy, y being the digit of units, and x being the digit of tens, or corresponding to tens, which means that our number is 10x plus y. So 10x plus y should be equal to 13 times the sum of the digits, which is x plus y. So 10x plus y should be equal to 13x plus 13y. That means that 13x minus 10x, which is 3x, plus 13y minus y, which is 12y, should be equal to 0. Dividing by 3, or factoring out the 3, we have that x plus 4y should be equal to 0, which means that y should be equal to minus 1/4 of x. Now this means that we do not have as a solution a number of two digits, because according to this, one of the digits should be negative. And as you can see, the digits have to be positive. Now then, we will assume that our number is made up of three digits, or consists of three digits. So our number will be the number xyz, which z is the digit according to units, y the digit according to tens, and x the digit according to hundreds, which means that our number is 100x plus 10y plus z, or z. So 100x plus 10y plus z equals 13 times x plus y plus z, or z. We have then that 100x plus 10y plus z equals 13x plus 13y plus 13z, or z. Okay, so 100x minus 13x is 87x. 10y minus 13y is minus 3y, and z, or z, minus 13z, or z, equals minus 12z, or z. So since we are looking for our smallest three-digit number, that means that we are going to assume that the digit corresponding to the hundreds has to be 1. So we make x equal to 1. That means that we have 87 minus 3y minus 12z equals 0. Factoring out the 3, we have 29 minus y minus 4z equals 0. Now, what happens if we assume that y is 0? Then we are left with 29 minus 4z. So y equals 0 is not an option because 29 is not a multiple of 4. So then we assume that y equals 1. So 29 minus 1, that is 29 minus y, 29 minus 1 is 28. So that 28 minus 4z equals 0. Factoring out the 4, we have 7 minus z equals 0, which means that 7 is z, or z, is equal to 7. This means that our number is 117. Now if we add up the digits, 1 plus 1 plus 7 equals 9. And 13 times 9 is equal to, well, 9 times 3, 27. We have the 7. We carry the 2. 9 plus times 1 is 9 plus 2 is 11. So 13 times 9 equals 117, and 117 is our number. So that means that the smallest number that is equal to the product of the sum of its digits and the number 13 is the number 117. 117. Okay, we are going to follow with our next problem in the next video.